Hello all, welcome to Code Hub. Today let us solve the LeetCode's daily challenge, and the problem is count of small numbers after self. You are given an integer array nums and you have to return a new counts array. The counts array has the property where counts of I is the number of small elements to the right of I. So what we can do here is what the problem states is that you are given an array 5261 and you have to return the count of smaller numbers except this self. So for on the right side, so for the smaller numbers on its right side are the 2 and 1. So there are two numbers which are smaller than 5, so we will be having 2. There are one number which is 1 which is smaller than 2, so we have to have it as 1. And there is one number which is smaller than 6 on its right, so the count of 6 is 1. And there is no numbers which are smaller than 1 on its right, so the count is 0. So this is the final array. Final output will be returning back from this function. That is, we have to count the number of smaller numbers at that particular index of that small element, and we have to make this count array. So this is what the problem states that. So how we can do is, for each and for brute force way, in brute force way what we will be doing is, for each and every index, for each and every element we will be counting on its right. We will be counting the smaller elements that is on its right, and we will be updating our counts. So the what will be the algorithm will be, so for I from 0 to n we will be traversing, and another for loop that will be running from j, where it will be starting from I plus 1 to n. And if it is nums of j is lesser than or equal to nums of I, then we will be just, if it is lesser, then we will be just adding our count plus plus, and then outside this loop we will be updating the count. So this will be the algorithm for in brute force approach. So what will be the time complexity here? The time complexity will be r of n square. So how can we optimize this solution? Because r of n square will be giving a time limit exceeded 10 power 5 into 10 power 5, it will be 10 power 10. So the obviously it will give TLE. So how we can optimize this solution? What we can do is, we can think of some binary search tree. Like we can form a binary search tree once, that is, consider we are having a 5 as root. Then if we are facing one to we next for next when we want to see, when we want to insert this 2 into our binary search tree, will be inserting to its left of 5, right? If we are inserting to its left of 5, then what we can say is, we can just increment one count. And we will be building for each and every element, we will be inserting the elements into our binary search tree, and we will be updating the counts, and that count we can take it as take the elements, and we will be updating our result array. So for this, it may seem like order of n log n solution, because for n elements we will be inserting the each and every element for height of the tree. But it is not that case, because if the elements are in sorted array, then we will be ending up forming a skew tree, which will be inserting for n elements. We will be traversing the n elements in the binary search tree and inserting the element to its left or right if it is sorted. So by this way it will also end up in order of n square solution, so which will be giving a TLE. So these are the two approaches that you can say to the interviewer. So how we can optimize this approach? For this problem, the prerequisite for this problem is nothing but the merge sort. If you know the merge sort, it will be a cakewalk for the problem. Or else we want, you have to learn what is merge sort, and then you have to come and see this video. So I will say the gist of what we'll be doing. 5261, if we take this, obviously what we are doing in our merge sort is, we will be dividing the array into two halves first, 5 and then 2. and then again it is 6 and 1. So again we will be dividing the dividing the array into two halves, which is 5 and 2, which is 5. And what we will be doing is, until the array becomes with a single element, we will be splitting the array at the center. That's what we will be doing in our merge sort first. After splitting the array into single elements, what we will be doing is we will be merging the elements. So we have splitted this 5 2 as 5 and 2. So each element will be in the single array. And what we can do is, we have to have a count array of size n, which is going to update our results. Initially consider all the results is 0. So this count array is nothing but our result array that is going to keep track of the numbers, smaller numbers, that is in the right side of that particular element. So we are just going to sort the array on the basis of this merge sort. So while doing the merge sort, what we'll be doing is, just we will check whether this 5 is greater than or 2. If it is greater, if it is 5 is smaller, we will be putting this 5 to our temporary. If 2 is smaller, we will be putting the 2 in our temporary array. So before putting into this temporary array, we have to do our process. We have to inbuilt our logic to count the smaller numbers that are after self. So what we can do is, consider we are having an I pointer here. Consider we are having an I pointer here, and also we are having a j pointer here. If this nums of I is greater than or equal to nums of j, then obviously we can say there is one element which is smaller than this 5, right? Which is one element that is smaller than the 5. So what is the condition? We will be just writing the condition also. If nums of I is greater than nums of j, right? If nums of I is greater than nums of j, then what it denotes? It denotes that there is a smaller number. So we will just increment our count, and then what we will be doing is, we will be just incrementing our j pointer. So here the array is exhausted, and consider we have sorted this array. What will be, so it will be is, we will be sorting into 2 and 5. So now the array is sorted. Now we will go in our recursive call, and we will be ending up this recursive call. We will be merging these two elements, 6 and 1. Similarly, we can merge these two elements. This also end up while this smaller number is incrementing, we will be just updating our count array as well. For this fifth element, that is at the first 0th index, we have to increment, we have to update our small count value, which is 1. But how we can know that this is 0th index, and this 2 is going to be our first index? So for that, we have to maintain the elements index also. So what we can do is, we can have a pair which is going to denote the element num, and the index. So if this is there, then we can sort this whole pairs. So consider we are having a data structure of pair which is having the num and index, and at that particular index we are going to update our count array. That is what we are going to do. Just have a blank idea, I will explain it. So now we are going to sort this array. While doing the sorting, we will be just updating our smaller numbers count, and then we will be updating our count array. So even this satisfies this condition. Nums of I is greater than nums of j. 6 is greater than 1. So there is a one element which is 1 is less than 6, which on its right side. So we will be incrementing a smaller number. Initially it will be 0. So smaller number is now is 1. Smaller numbers count is now 1. So for this particular sixth index, for this particular index, that is 0 1 2 3, 0 1 2, so second index, at particular second index we will be updating our smaller number value, which is 1. We have just incremented this. J will be incremented and J is exhausted, and then we will be putting the other elements into a temporary array, and we will be proceeding further. So now we will be having an array 1 and 6. Now we will go to our next merging process so that it will be more clear. So now the merging process is here. What we will be doing here is we will be having a I pointer for this particular array, and we will be having a j pointer for this particular array. If you know this merge sort algorithm and how merge sort works, then it will be easy to understand. So my suggestion is to learn the merge sort before the coming and seeing this video. So we are having an I and we are having a j, and now we have to check the same condition. If my nums of I is greater than nums of j, yes, this 2 is greater than 1. So what will be incrementing? We will be having a smaller number as 0. So now the smaller number is incremented to 1. Next we will be moving our j pointer. Next, we are checking again with the same condition. Nums of I is greater than nums of j. It is not so. So we will be coming to our else part. In else part, what we are going to do is we are going to update the index of 2. That is, index of 2 is nothing but 1. So 1 to the smaller number. So we will just, what we are going to do is nums of I dot index. At that particular index we will be just incrementing. We will just increment with the smaller number value. Hope you understand what I'm doing. So since we are coming in this inside the cells part, we will be updating the counts array. Counts array, the nums of I dot index is that nothing but the 2 index which is 1. So at 1 we will be just updating the smaller number value. Smaller number value is 1 currently, and then we will be moving our ith index. Now I plus plus is done here. Here we are doing j plus plus. Okay, hope you understand this. And then we will be incrementing the j plus plus. Next, what we'll be doing here? Next, I is at 5 and j is at 6. Even here 5 is less than 6. We'll be going into this else part. Now count of nums of I dot index. 5 fifth in, for the element 5, the index is 0. For at 0th index, we will be incrementing with the smaller number value. Smaller number is 1, so it will be incremented with 1 plus 1, which is 2. So and finally we will be incrementing the ith pointer. So we have incremented the ith pointer, and it is exhausted, and this also exhausted. So nothing but we have done the merge process, and finally we have got the count array. We have to take the condition whether if the one array is exhausted and other array is, then we have to take that condition. So this is the whole merge sort approach. Hope you understand this approach. Let us code this solution lively so that it will be more clear for you. First, what we want to do is we can take the size of the array n equal to nums dot size. So first we will declare the size of the array. After declaring the size, we can just we have to create a index, right? So we'll be having a struct. We'll create a data structure called as pair. This is going to have our data structure, which is nothing but int num and int index. So we have the num and index. Num is nothing but the element, and then index is going to be the value. And first we have to update our index. So we will have a vector of this pair, and what we can do is we can have we can name that vector as array of size n. So we will be updating the index. Int I equals to 0, I less than n, I plus plus. We will be saying that array of I equals to nothing but nums of, sorry, array of I is nothing, I dot num. Array of I dot num is nothing but nums of I, and array of I dot index is nothing but I. So this is how we will be we'll be updating our index, that is keeping track of indices. That's what we are doing here. After this, we will be creating a vector int count array of size n, and initially let it be 0, and finally we are going to return our count array only. So before that, we are going to call the merge sort with the we are going to pass array, then left, then our right, and we will be passing our count array too. And we can write a private function merge sort, void merge sort, which is vector of var array, and this is nothing but left, and this is nothing but right, and a count array vector int ampersand count. And inside this merge sort, we are going to split the array until the elements are going to become one. So my right if my right is going to be less than or equal to my left, then we can just return it is having one element or more less than one element. So if that is the case, then we will return, or else we will calculate its mid. Mid is nothing but left plus right minus left by 2. This is to avoid the overflow. And after finding its mid, we are going to call the merge sort with those updated values: array left to mid, then count array, and similarly we'll call the merge sort array mid plus 1 till right count array. Then we are going to merge the each recursive calls, each elements in the array. So we will call the merge function with the passing the values array left, then mid, then right, then count. So we want to write the merge function now. So the merge function is nothing but it is going to be a void merge function. We can just copy this parameters to our merge function. The extra parameter is mid, so we will have a mid value. And then what we are going to do here is we are first want to declare three variables. Int I is going to start from left, then j is going to start from mid plus 1, then k is going to start from 0. So we will be declaring a vector of pairs. This is going to be a temporary array. We can temporary array, and we can have the size to be right minus left plus 1. So this will be the size of the temporary array. So first what we are going to do is we will be going till I is less than or equal to mid, and my j is less than or equal to my right. So inside this while loop only, we are going to incorporate this idea, this if else condition. So what we'll be doing is we'll be initializing in smaller number, which is initialized to 0 initially. So if my nums of nums is not, it is not nums, it is array of I dot num is greater than array of j dot num, then this is the case. Smaller number, we can just increment the value, and then we can just increment j pointer. Before incrementing the j pointer, we are going to copy it into our temporary array. So temp of k plus plus equal to array of j plus plus. That's it. Whenever we are coming inside the else condition, we are going to update our count array. We are going to get the array of I dot index plus equal to the smaller number. Then we will be doing the same value, that is temp of k plus plus is nothing but the array of I plus plus, array of I plus plus. So once we come outside this while condition, either one array will be exhausted. So we have to copy that array. So while I is less than or equal to mid, we can just copy this case. That's it. We'll be copy this case. Similarly, while j is less than or equal to right, we have to copy this case. That's it. Now either one of the array is exhausted, we will be doing this. Okay, fine. Next what we have to do is we have to copy the elements to our original array itself. So what we can do is we can run a for loop. Instead we can initialize the I to be 0, initialize our I to be left and j to be 0, or else we can say it as k equal to 0. So while I is less than or equal to right, we have to come inside this loop and we have to say array of I plus plus is equal to nothing but temp of k plus plus. So we have just copied the temporary array to our array. So this is the sorted array, we are copying into our array. So we have done the merge function and we are ready to go. So let us run our code. Let us see whether it is failing. I hope we have done correct. It is passing. We can just use the example test cases. It gets accepted, and hope you understand the code also, since I have given a clear walkthrough. So the time complexity here is nothing but n log n. For a worst case also, best case also, the merge sort works for the order of n log n. So which is the best time complexity we can say, and we will be using a extra space of order of n, which is the temporary array. So this will be the space complexity. So that's it. Let us submit our code. Superb, it got accepted. Hope you like this video. Let me know in the comments if there is any clarifications to be done. Let us see in tomorrow's LeetCode challenge. Until then, bye.